Hi folks, glad to see you back. We're going to look at 1.1 from the textbook, which is outcome R2, and we're going to be doing horizontal and vertical translations. So basically what that means is we're going to be moving the function or relation horizontal, which is left or right, and vertically, which means up and down. Okay? So the first thing we're going to do is we're going to start with the graph f of x equals x squared. And just so that you recall, y equals f of x. Okay, this is just function notation, just noting that we're talking about a function with x as its variable. All right, so first thing, just if you recall from previously, x squared is a parabola. It's got a point at 0, 0. If I choose x equals 1, x squared equals 1, and 2, x equals 2, y equals 4, and if I choose x equals negative 1, then y equals 1, and negative 2, y equals 4. Okay? So when you're drawing your graph, make sure your parabola looks, it's a nice rounded curve over here. Don't make it pointy at the end. All right? So make sure it's nice and curved and it's sloping ever so gently. And on the ends, you want to make sure that you put your arrowheads because it's continuous. It's just keeping on going on either end. All right. So we're calling this parent function. It can also be called the original function. All right. So it's the original function, and now we're going to start doing things to it. So over here in our sketch of g of x, we are going to change this original parent function by moving everything down 2 units. Now this means this, if we have this minus 2, notice that it's outside of the x's. It's it's acting on the entire function. It's acting on the entire x squared. So if I set up just a quick table of values over here, so that's my x value, and then I've got my g of x, which is x squared minus 2. I plug in x equals 0, I will get y equals negative 2. If I plug in x equals 1 in here, I will get y equals minus 1. If I plug in x equals 2 in here, I will get 4 minus 2, which gives me 2. Okay, so that's going to start me off plotting a couple of points. Now the first one here is going to go right there, and then this one here is there, and 2 comma 2 ends up right here. So we can see that there's a relationship here with these points and these points up here. So let's see if we can guess what the other one's going to look like. Okay, I'm just going to sketch this in. Okay, and do you recall about the axis of symmetry? If we look at that and we can kind of use the axis of symmetry to plot the other side of it. And if you want, you can double check these values, so you can plug in x equals negative 1 and x equals negative 2, and you can get those points and graph them, or you can just trust me, I suppose. So if we want to look at these, it's probably better that you maybe check it yourself if you don't believe me, because you'll get a better understanding doing so. So now let's look at this graph, g of x, and let's compare it to our original parent function. So what do you notice about the vertex? Where has it moved? How has it moved? So if you look at every single point, it has shifted down 2 units. All right, so we've got a movement of downwards of 2. All right, now let's have a look at the next example. So we've got h of x. So h of x, now we've got x minus 1, and that's all squared. So remember how we had f of x equals x squared? Now what's happened is, and I'm going to erase this on purpose, we're substituting that instead of just an x, we've got an x minus 1 now. So it's no longer f of x, we're going to call it h of x because there's been a change applied to it. So how does this change affect our graph? Well, we can do the same thing as before, just a real quick table of values. So x, and we've got x minus 1 all squared. If I choose x equals 0, I get y equals 1. If I choose x equals 1, I get y equals 0. X equals 2, I get y equals, so I plug in a 2 here, and then I get 1. If I choose x equals 3, then I get y equals 4. Okay, so let's plot these points and see how my original function has been changed. All right, so 0, 1, we've got 0 on my x and 1 on my y. I've got 1 on my x and 0 on my y. I've got 2 on my x and 1, 3. I've got 4, so that's up here. That runs into this title that I've written in here for my table of values. Okay, so you can kind of see what's happened to the graph, right? So let's draw this in. Keep my curve nice at the end there. Put an arrowhead there. And I'm just going to use the axis of symmetry of x equals 1 here to move that over there and sketch the rest of the graph. All right, so we've noticed I said something about x equals 1 as being my axis of symmetry. Remember that? Remember that from last year? Here we had x equals 1. Okay, so that's kind of related. It's important. So we are going to notice how this is been changed from here now to here. So everything has been moved over. All points shifted 1 unit to the right. So we're going to say that way 1 unit. That's our shift. Okay, now let's have a look at this last example here. On this page, we have 2 things happening. So if you were to remember the whole axis of symmetry bit that we did in grade 11, what do you recall about this? Where would the axis of symmetry be? Okay, so remember the whole idea of opposite to the connecting sign, and we had this kind of discussion like that, remember? So your axis of symmetry is going to be on x equals -2, so it's going to be somewhere along here. So this is where our parabola is going to be going anchored there. Okay, so now let's actually plot this and see what happens. Well, or we could just use that information and the fact that we know this is going to be 1 unit up. So this is going to be shift 1 up. And this is going to be our axis of symmetry here. So where, if our vertex was here before and our axis of symmetry used to be on x equals 0, now it's on x equals -2, and our points are all shifted up 1. So now our new vertex is going to be right there. And then everything else moves over 1 up and 2 to the left. So this is what our parabola, our parabola is now going to look like. All right, to double check, what you could do is just prove it to yourself by setting up a table of values and choosing a couple of numbers here. You could choose +1 if you want, and see what values you get here. So for 0, you get 5, 2, 1, 2, and you get the idea. So you can see what the value for 1 ends up being way up here somewhere. Okay, so let's write down in words what happened here. So all points shifted 1 unit, make that a 1, 1. 1 unit up and 2 units left. All right. Now, our next example is going to be looking at the absolute value. So right here, we've got the graph of y equals x minus 2, the absolute value of x minus 2, I should say. So this is what we're going to start with, and just to make note, it's a good idea just to write down what the points are so we can see where they end up going. So this is now going to be our original function that we're using, and we're going to apply the transformations to this. So we're going to either shift it up or down or left or right. So according to what we just did on the previous page, this is going to be a shift left. All right. Now, if you want to dissect this a little more, just to notice why it's a shift to the left, the original kind of the standard function kind of goes x minus something, right? Now, if we look at this and we put a bracket, we call it -3, we see if we simplify, we end up getting x plus 3. So this is why this is a shift 3 to the left. So shift 3 left. All the points of this original graph that's dotted here for you get moved over 3 to the left. So I'm going to take this and I'm going to just go count across 3. I'm going to take this point here and I'm just going to count across 3. And every point I'm just going to go count across 3, count across 3, count across 3. Okay, so now what you need to do is, since these are straight lines, it's always a good idea to have some type of straight edge for you. I've got my Crime Stoppers card just because it's handy. Put arrowheads on the ends. Okay, and now you've got your nice graph of f of x plus 3, which is now going to be called g of x. Okay, so if you want to hit pause and try this one yourself, see what happens. I'm not going to spoil it for you, so hit pause anytime. Okay, so either you hit pause or you couldn't find the pause button, or which you could just use as a space bar, or you did and you actually tried it and you notice that here this is going to be a shift of 2 units up. So everything goes up 2 units, up 2 units. Here, 2, up 2. Okay, and then you're going to redraw your graph with your ruler or straight edge, straight line. Okay, now that's your graph of h of x. Ta-da! Good job. Okay, now we're going to put both left and right or up and down shifts together, and we are going to do it all at once. So this here, or should he hit pause? Do you want to hit pause? Why don't you hit pause? Hit pause and try this one, and then we'll come back and do it. Okay, so we're back. I couldn't wait any longer. So here, notice that number there, that's a +1. That's connected to the negative. So that means that it's 1 unit to the right. And this over here means that everything moves down 2 units. So we're going to do both of these together. So let's start here at this vertex, and we're going to go 1 right, so that's that way, and then 2 down. That's my vertex. I'm going to take this point, I'm going to go 1 right and 2 down. And I'm going to go over here, pick this one, go 1 right and 2 down. 1 right and 2 down. Okay, so then I've got my graph here. Sorry, my straight edge. Make sure you're putting arrowheads on the ends. Use a straight edge, make it look nice and pretty, folks. Okay, and let's label this point, I don't know, just for fun, I guess. It's always good to indicate some type of point or scale just in case it's not already indicated on the graph. All right, so that's the end of this one here, end of this video. I'm going to stop here, and we'll continue in the next video. Okay, good luck.